So in this example, we are going to be determining the size of an MP3 file. Now keep in mind that CD quality sound is the highest quality that anyone can purchase or have. And CD quality tries to capture as much of the natural sound as possible. But often in the capturing process, much of the quote-unquote sound that is captured is dead air or simply imperceptible sound. So a process of removing this dead air is known as bitrate compression, which is identified as an MP3 format. The greater the compression ratio, the lesser the overall sound quality. However, you wind up gaining a lot more in data storage. So the data transfer rate for CD quality is 16 bits per sample. So we have this chart here with common bitrate transfers, and these bit rates are in kilobits per second. And these are the most common ones. And next to them, we have their accompanying compression ratio. So for this example, it says, suppose you want to download Before He Cheats by Carrie Underwood on your MP3 player. Determine the amount of storage used for the following bit rates. So for here, for A, we have 96 kilobits per second. So 96 kilobits per second has a compression ratio, and this is read as 15:1. Now, in an earlier example, we determined that if Before He Cheats is recorded at CD quality, it would use up 33.48 megabytes of data. So to be able to figure out what the compression is, how much data would this wind up using if we use one of these compression ratios, 96 kilobits per second, that has a compression ratio of 15:1. All we simply do is divide this by 15. Dividing this by 15, and this comes out to be approximately 2.2 megabytes of data is used. So we go from about 33.5 megabytes down to 2.2 megabytes. So you get a lot more storage on your music device than if it was left at a higher quality. So for B, same idea. Originally recorded at 33.48, originally recorded meaning at CD quality, 128 kilobits per second. That has a compression ratio of 11:1, so we simply divide by 11. That comes out to be approximately 3 megabytes. So as you can see, as the bit rate goes up, the compression goes down, and of course we wind up using more and more data storage. For C, at 160 kilobits per second, we take our original recording at 33.48. Here's 160. That's 9:1. We simply divide by 9, and that comes out to be approximately 3.7 megabytes of data. And finally, for D at 192, we do the same thing. 192, that's at 7:1. We divide it by 7. That comes out to be approximately 4.8 megabytes of data storage. And there we go.